Hello. Sorry, I've been a bit late. I tried to practice my talk, and I failed. So this is the pitfalls of real-time-ification talk, and we're going to talk about Rails and real-time web applications, and I would like to start with Rails. As many speakers before, I would like to refer to the renewed homepage of Ruby on Rails, just because I wanted to find, some good starting point for this talk, and I found it. That's an interesting, catchy phrase, like build amazing web applications. Rails got everything you need, but it doesn't answer the question, what is amazing? And I started thinking about it. Okay, what is an amazing web applications? Well, first of all, if you ask people on the streets, they will tell you, oh, that should be sleek UI, it would be beautiful, all the roses, whatever. That's kind of true. That's amazing. Some people would tell you, especially in this room, that it shouldn't have any JavaScript. I would agree. That makes sense. But I also would tell that in the modern world, like modern web, thank you, one of the properties of amazing web apps is being reactive. And that's a question. What the hell is reactive? How could you define that? And I would like to define it by providing an anti-example of a non-reactive interface is the one that forces you to hit F5 button to upload, to reload the page to see the updates. You shouldn't do that in 2020. That's not reactive. Reactive is when you receive updates whenever they happen in the system. Immediately or not, it's questionable, but that shouldn't be a user action to get the information which has happened beyond the user flow. And technically, we usually do that through some kind of streaming functionality, usually through WebSockets, and hopefully we already have that in Rails since 2025. So the real-time-ification of Rails began 7 years ago with Action Cable. And I can't say it was really highly adopted in the early days. And the real boost to real-time-ification was just a year ago with Hotwire. And I should mention that in between those events, there were also an appearance of Steam Universal Flex framework and its ecosystem, which is amazing, and which allowed you to build reactive Rails applications without JavaScript for already several years. But in this talk, we're going to focus mostly on Action Cable and a little bit on Hotwire. So a year ago, I gave a talk, kind of, online, on the new way of building Rails applications, new front-end, new modern front-end Rails applications, and one of the key features of them is HTML WebSockets. And I kind of tried to sell you this approach, right? So it's amazing, just use it, and you're gonna be cool, no JavaScript, everything's just gonna work. Yeah, just drop Turbo Rails into a jam file, or it's already there, right, for Rails 7, and you're good to go. You have everything for free. And I have to admit, that was a lie. That's not for free. You still need to think about this new way of doing things, of real-time things, and that's why I'm here today. I want to show you the problems you might encounter and how to solve them. My name is Vladimir. I work at Evil Martians. I'm kind of digging rubies, hunting gophers as a principal backend engineer, and I'm currently residing in New York. So if you want to talk about Ruby, Rails, or life on Mars, feel free to reach me. So I'll be happy to meet with humans. I'm a yesterday's Rails contributor, so you can find me mostly with Action Cable related stuff. And I'm working on any cable, which is I'm going to talk about a bit today, but not only about it. Yeah, I'm not promoting it. Maybe I should. So also, I started a screencast series on Christmas. That kind of sounded like a good idea back in the days. In this screencast, I'm kind of exploring the possibilities of Rails 7, Hotwire, and any cable playing together and solving some problems. And I'm going to use the demo application of this screencast. That's why I'm talking about it today for demonstration purposes. So you can learn more about it on YouTube. OK, let's move on to the talk. So what has changed when we started doing real time? What is a shift, like a paradigm shift here? We used to write request-response applications. like, you know, synchronous, give me something, okay, here's your payload, or maybe you fail or not, but it's kind of predictable, like one client, one server, and they communicate to each other. With WebSockets, things a bit different. They, first of all, asynchronous, they bidirectional, the data flow is kind of continuous. You don't know when a server would decide to send you data. You could expect it anytime. And you'd have to deal with delivery guarantees. So even though formally this is still HTTP, you should know that WebSockets actually not HTTP. Yeah, Aaron did a great job explaining the difference, actually, so I can skip most of it. So what's specific with Rails is that actually Rails did a great job on hiding this difference under the familiar APIs. You know, you have channels for WebSockets and controllers for request response, and kind of similar. They, like, experience of working with them is similar, but under the hood, they were different. And with Hotwire, the situation kind of like evolved a lot. So, you know, now you don't even write client code or whatever. You're just dealing with HTML. You know, the magic is happening behind the scenes. And that leads to the pitfalls I'm going to talk about. And let's start with the first one, which I call personalization. I could be louder. Just a second. OK, let's return to our request response and real-time difference. So with request response, a client requests something, and the server generates a payload just for this particular client and send it back. With publish subscribe pattern, which is kind of a pattern we use for WebSockets, we do broadcast the same payload to multiple clients. So it's kind of duplicated at the engine level, whatever, it doesn't matter. But the thing is, it's kind of the same data to everyone. And that leads to many questions. Like, hey, I'm using current user in my template, but how can I broadcast this template to other users? Ooh, I don't know. Or how to send data to everyone, but not this particular user. Like, there is no such thing. Like, this is publish, subscribe. We don't know about users. We know about streams. And we could split this problems, there's a set of problems, into different categories. Like, usually it deals with permissions or localization. But now for this talk, I would like to talk about the typical messaging problem. We want to show a current user messages for this user with a little bit different UI, different accent, like color, position, whatever. But we still broadcast the same data to everyone. And that's kind of the thing you face first when you deal with real-time. I've been working with junior Rails developers for a long time at a boot camp, and I know which techniques they try to accomplish to solve this problem, and they kind of repeat them forever. So I would like to share them and tell what could be wrong with this approach. So very first attempt to do is could be like, OK, we just send create message to an AJAX request, and we return some data in response for this particular user, and everyone else get updates through cable. Like, easy, like just no need to change anything actually, except like stopping current user in broadcast probably, but that's it. The problem is that user may have multiple tabs, multiple devices. It's not the case for every like real-time feature, but for chat it's pretty common, and you can find that something inconsistent behavior here. OK, so we should remember that current user is actually not current connected client. There are two different entities. Another problem that could appear here that cable updates and AJAX responses are actually like unsynchronized. So there could be race condition, and you can end up with some strange UI artifacts. Another approach, OK, let's move on. We want that whenever a user connects to multiple devices or a single one, we would like to what's wrong with this approach? We actually kind of break the whole idea of PubSub because it's to broadcast data to streams to multiple users under the hood without knowing about them. And with this approach, what we can do is just send in a lot of broadcasts for every update. And we cannot use the fact whether user online or not by hacking Action Cable internals and looking into the subscriber implementation, because it's not fair. So we shouldn't do that. It will break one day if, when the internals would upgrade or whatever. So there's a significant overhead of sending data to not connected actually users. And I call this there is a term like online selectivity. So if we know their number of total users is low, and they most likely connected everyone, that's okay to use this approach and just go with it. But if you have 2 connected users and thousands of subscribers and thousands of broadcasts, it's just doing a lot of useless work. One thing I want to mention in the context of this channel per user approach is that there is a similar thing, but I call it channel per group, but not like your business logic group, but some kind of a technical group. For example, you can send data to different locales or different permission roles. And in this case, you just have a constant number of broadcasts per update, pretty low usually, and that's a good enough trade-off for not implementing, for example, client-side internationalization. You can just do multiple broadcasts. A good thing is with Hotwire, for example, where you probably have encountered this problem, you can do that just by this simple patch. Just prepend the streams. I have it, but I don't know what to put. You just prepend the streams of locale, and you just perform broadcasts to all available locales. Just 10 lines of code. And now your Hotwire app speaks English, Spanish, Russian, whatever. OK, let's move on to the next bad practice, which is quite popular. We can send updates through this WebSocket, like message updated or edit, and then client perform AJAX requests to get their version of this update. And, well, in the world of Hotwire, that might look like this. Very elegant way of doing this is to send in turbo frames without any contents, but with just a source URL pointing to the contents. So whenever a client mounts this element, it performs a HTTP request to get the data. Nice, like magic. But imagine you have thousands of clients and heavy chatting application. That could blow everything up. And I would not recommend doing that. And since this is not a keynote, it's just a regular session, I have to have solutions. So the name I came up with this solution is quite long. So the idea is to broadcast some kind of unified data, context-free, speaking technically, and apply some client-side enhancement. Yeah, we have to write JavaScript, sorry. And I already described this approach in the blog post a while ago, about a year ago. So I'm not going to recall it in details, just a couple of code examples. So we're just doing some client-side logic for messages, mine, theirs, adding classes at the CSS level, and that's it. Similarly, for Hotwire version, we can use custom HTML elements or stimulus controllers, it doesn't matter actually, to do the same. So whenever an element appears on the page, we first check whether it has the attribute with current user, compare it with current user, and add the corresponding class. The interesting thing that this approach is used widely. Again, we know some existing tools. Can you guess the application I was digging in? No, OK, that's a Basecamp. And they kind of use the same approach with data attributes, with data visibility attributes, and I guess stimulus controllers to just hide delete actions for not yours messages or whatever. So this approach has its benefits, it scales, but it requires some client-side specific logic. And that's a common problem for all the personalization approaches, because you need to implement something particular for this real-time feature. There are two ad hoc. And I was thinking, well, there should be a way to build personalized updates, like payloads, broadcasts, without thinking about it, kind of. Because that should be solved by someone. And we'll speak about others in the context of real-time. We can avoid talking about Elixir sorry, and Phoenix. We kind of, that's a good idea, to inspire from other friendly frameworks. And how live view works. They don't have that problem, like, by definition. Why? Because they do not broadcast data directly to clients. Their updates go first to the Erlang process, which is kind of represent the server-side state for the particular component. And that process, this server-side component, just transmit the updates to the client. And these updates kind of context dependent. Okay, so this is Elixir, Erlang. We far away from that, yeah, but we still have something similar. Actually, with Action Cable, we can have stream from callbacks and do the same. For every client, we can perform this message, like partial rendering, transmit this append stream element. That's gonna work, at least for pet projects, that would be totally fine, unless you, like, again, hit a large number of users. And rendering the same partial thousands of times, well, I guess it would require some interesting optimizations to avoid, like, really doing that. And even for the current Action Cable streaming implementation, we have some problems with double JSON decoding and encoding for just nothing, which I tried to address many years ago. Well, so many, but it's still there. But you can take a look at this pull request to see the effect of using stream callbacks, actually. Another reason why I'm not recommending this is it's not supported by any cable, sorry. Okay, let's move on to a more interesting part, consistency or delivery guarantees. Action Cable states that any data is transmitted to connected clients. It's sent directly to all the subscribers. The thing is, send is not delivered. That's the difference, especially when network is unreliable. That means that Action Cable provides the at most once delivery guarantee, or fire or forget, or I don't care whether you receive this message or not. And that's the source of problems. You probably, you don't see them unless some users would start to complain, hey, I'm not seeing chat messages others see. That's something wrong with your software. Yeah, we're all using it. It's wrong, but it's okay. So yeah, network is still unreliable. Let's take a look at the video one more time of the unknown application. So imagine I'm riding subway somewhere, like New York City, no mobile internet in tunnels, and I'm speaking with someone in the application with my mobile app. It's not connected. People telling me some interesting stuff. And OK, what do I expect? OK, I go back online. I should see the same state as others, right? Like, let's check it. Maybe that's something wrong, right? Here we have only 2 messages, and here we have 3. This one haven't been delivered to this client. That's not a big deal in this particular situation, right? That's just a random question. But what if someone told me, I love you, and I did not tell back? Like, that could be the problem, And that's all because of our spoiled software, and just because we don't understand the problems of the underlying technology. OK, we're going to solve it today. But first, let's take a look what's happening under the scenes. So at the kind of a network layer. So we perform the connect request, like an HTTP request, upgrade, whatever. A server responds with welcome message. This is handshake. We're trying to initialize our connection, our Action Cable client. Then we perform subscribe requests, and we receive confirm. OK, now you subscribe to live updates. And now you receive them. And everything is good while it's still on the station. And then you go to the tunnel. Connection is lost. Server send updates. Like, server continues sending updates, right? But they're not reaching the client. Now we back online. We perform all the steps again. Like we perform a handshake, resubscribe into subscription, and we continue receiving the updates. And the thing is that there was, oh, sorry, OK. Let's watch it again. There was a large period of time. I don't know how to move fast with animations. OK. There was a period of time when you haven't received anything, right? And you don't even know whether there were updates or not. Server doesn't tell you about it. And we need to fix it somehow. What would be the kind of approach on dealing that? Well, first of all, we need some source of truth. We need some data which we could use to restore the state, usually a database. In our example, it's just a messages table. OK, we have it. Then we just need to request this data after reconnecting. And to be more precise, we actually need to request this data even if we connect for the first time, even if we have a stable connection. Because there is another problem, which is kind of the same but different representation, which I call late to the party. Let's go back to our animation. OK, so before we start initializing our client, we actually either receive an HTML version of the page or perform AJAX request to get the initial state. So there is another action before our real-time communication. Then, again, the same stuff happening, broadcasts, and this. So there could be live updates in between we started to initialize our client and the page was loaded. That's what I call late to the party. So especially with Hotwire, we render the initial state in the HTML, but it takes time to transmit this HTML back to the browser. And during this period, there could be other updates which were not handled by your initial state. OK, let's skip the video. It's slow and it's boring. So I already told that. So it's not about unstable connections, because some people tell me, oh, our application is only used by people at offices. They all have 1 GB connection and they're good. OK, but they still load in pages and loading data. There is a startup process of the application. So what we should do here, OK, let's perform additional requests and ask server to return some history, I call it, for this particular channel. And it could be implemented like this. We have a connected callback. We just perform history, and a history action it does whatever it needs to retrieve the missing messages. So that's up to you. That's your responsibility to implement this logic. Problem solved, or is it? Again, more animation. Actually, this is a continuous process of sending messages back and forth. So there is at any, and if it's continuous, not discrete, there are infinite number of points where the data could be sent by server. So it could be sent right after we subscribed, but before we performed history request, or right after we performed request, but before we received the history itself. And that's tricky. So in order to, that could lead to this situation. That could lead to inconsistent messages order or even duplicates in your application. OK, let's fix it. We can add a kind of state machine behavior to our subscription, like pending state. We can add a buffer to keep all the payloads which happen while we were receiving history. And we need to add a history acknowledgement mechanism because Action Cable doesn't provide one. Now we're good. We solved the problem. We also should take care about idempotence, because that's what makes our almost at least once delivery guarantee to be exactly once for the application, because that's what we want. We don't want to show duplicates. And the easiest way to implement it exactly once is to do that client-side. So clients should just keep track of messages it's seen and just drop them if they're received again. For this use case, we can just check whether the message with a particular ID is already on the page. And if it is, just don't update it. Or alternatively, you can remove the old version and add the new one. So that's a different approach. This solution is still not that good from my opinion. We have to write a lot of code. Most of it is specific for a particular feature, like a particular model, whatever. The way you retrieve history is the way you're dealing with idempotence. And Hotwire doesn't have any JavaScript, right? And we added a lot of JavaScript to make it work. Well, Hotwire is just HTMLs, some custom HTML elements. And under the hood, Hotwire has a very, very minimal subscription implementation, very simple, which doesn't care about consistency. So I decided to fix it, and I came up with the idea of like turbo history stream. It's a custom HTML element which has the same kind of stateless subscription implementation with pending messages and so on and history. And that's how it could be used universally. You just tell Hotwire which element should be used as a source of like a cursor, yeah, which is going to be used with a history request. And you just make a method in your model and transmit data in response to it directly to the socket who requests the history. It works. We can use it, well, if you want, for free. So check out this gist. Good news about Hotwire, it is already idempotent. It's built into the framework, so we don't care about it. That's solved. That's really great, because otherwise we will have to hack Hotwire itself. It's like a totally different story. OK, sounds like we have a solution, but I'm still not satisfied. Why? Because I don't think like our models, like speaking of Hotwire, should take care of like network consistency, network failures. That's like very far away from model layer, right? And I don't think applications should either care like even at any layer about this. We have a WebSocket server. That's its responsibility to take care of consistency. And that's where I'm going to talk about any cable a little bit of version like 1.5. Let's go with 1.5, which actually support that transparently through some protocol extensions. You can watch some videos of how it works. I posted them on Twitter, so let's skip. That's more interesting. So we have to extend Action Cable protocol. Why? But just because currently it doesn't carry any information about the message position in the stream, for example. That's what we need to implement the history functionality. And we need the history command as well, which is handled by the server. Your Ruby app shouldn't care about it. So that's up to a client-side application and the server. It's a protocol specification. And with this, you get consistent updates for free. So your application code stays the same. Want to use Hotwire with that? Feel free. It's just going to work. Just swap the client and the server for like any cable client and any cable server, and you're good to go. That's it. It's kind of available in the preview version, but I'm still figuring out the final APIs, so you can try and give some feedback. A particular use case for consistency. Yeah, we have 5 minutes, OK. Is a presence tracking. So sometimes you want to know who's online, like when people leave, when people join. That's important for many applications. And how to accomplish that. One approach is to build an online channel and just use subscribe and unsubscribe callbacks. But you probably already see the problem with this particular implementation, right? So we already learned that people have multiple clients. So that's not an option to just using flags. OK, we have a new shiny K-Redis library. Let's use counters. And that's kind of a better idea. But I think for this use case, we also need something more like generic presence tracking implementation. And I even wrote about it years ago, like proof of concept, like just an API that could look like Action Cable presence, which will allow you to include it into any channel you want and have a consistent view of who is online or broadcast events or whatever. It's available online. But there is a problem. We're talking about consistency. Actually, not about how to track like users in the database or Redis or whatever. The way all the presence tracking functionality works is we usually use subscribe callbacks and unsubscribe, which are actually disconnect callbacks. And the thing is, are we sure that these disconnect methods called 100% of time for all the connected clients? And actually, we couldn't be sure of that, at least today. Why? Because there are some situations. So a server could crash. You know, you loaded thousands of active record models in memory, got an out-of-memory exception, and server just dies, and it doesn't have time now to perform all these disconnect calls. Or even if you shut down the server like gracefully, there is usually like cloud providers like Heroku, graceful period for shutdown termination about 30 seconds. And it couldn't be enough for performing thousands of disconnect calls for all the clients that were connected, if you have many of them. If you have hundreds, that's okay. That's enough time. But for large scale, that could result in missing disconnect calls. And that would mean that you have an inconsistent state in your presence tracking system if you're just using online, offline, or counters or whatever. In order to solve this, we need to add some kind of heartbeat for presence. So we need a client to perform some kind of regular keep alive requests, like I'm still alive, just in case you're going to crash and lose this information. We're going to use the timestamp of the last keep alive and use it to calculate whether you're really alive or you haven't been sending these keep alive messages for long to probably disconnect it. And one particular way of doing this is to use Redis order sets with score and just sort by score. Use timestamp as score to get who's online. And I've implemented that for Hotwire. Very simple application. We're just tracking the number of users currently watching this channel. So nothing fancy. But under the hood, we actually use HTML. We use a concept of online users, and we can print the list of them or whatever we want. And that's also done for the specific method defined in the model. Yeah, I don't like this way of doing things yet. So it's just for Hotwire people. So I'm not recommending adding everything into the model, just in case. But this turbo presence thing is responsible for tracking, for handling keep alives or whatever. Again, this requires custom HTML elements, so turbo stream, presence, source, whatever. And it comes with this gist. It's pretty stable. You can use it. There is a Redis order set implementation for tracking with expirations. But keep alives, and we need to add a custom HTML again. It sounds like maybe we don't need to send keep alives from client to server. Well, while client is working, it could perform kind of keep alives on its own inside. And that's actually how many WebSocket servers does with presence support. And that's, again, the goal for future version of any cable, to add protocol level presence support with just keep alives inside and all this Redis stuff inside. You don't care about it. All you need is to have a presence reading API, so to get the presence information for a particular channel. And the plan is to implement it with something like Redis functions or whatever, so you don't even need to know the underlying structure of this storage. But that's coming anytime soon. Oh, not soon, anytime. OK, I have to finish because you want to have some lunch, I guess, and we started late. There are other pitfalls I just want to recall. Transport. You know, it's still a problem for some kind of applications, usually like government or financial, that they use software which prevent them to connect through WebSockets. They still need fallbacks, like long polling, short polling, whatever. And we don't have it for Action Cable. We don't have it for any cable either. So, I can implement it, but, I believe that we should get rid of this software which blocks us from using WebSockets. HTTP3 is coming. I would better implement web transport than long polling, but that's still a problem. You should consider it if you want to do some real time for these kind of applications. And performance. Performance is a topic I usually speak about. And of course, it's a solved problem. You can just use any cable. But if you want to learn more, you can go to anycable.io and learn about it. If you think that I wanted to tell today that real time is difficult, avoid it. That's, well, might sound like that, but that's not true. I wanted to tell that real time is different. You should keep this in mind. So this is a different way of building applications. And you need to learn what lies inside, under the hood, WebSockets, all this asynchronous stuff. If you know that, if you keep this in mind when building features, you will ship beautiful software, amazing web applications. Yeah, amazing web applications. So just try to avoid the pitfalls, and you're good to go. And as a final announcement, just to recall, I'm working for Evil Martians, and we help in building beautiful, amazing web applications. So performant, real time, whatever you want. And we're building a lot of open source stuff, you probably know. So you can find me and my dear mustache friend Alex here at the conference and ask any questions. And finally, one more link or QR code to scan as a special kind of a, I don't know how to call it, gift to RailsConf attendees or whatever community. So, you know, we have a pro version of any cable, and probably some of the features I mentioned we're going to be first introduced there, not in the community version. So we give it for free for 6 months for anyone using this link. Feel free to share it, not a problem. So let's make real-time web in Rails better. Thank you, and I also have some stickers.